Soviet space program. The Soviet space program, Russian, Kosmyskaya Programa SSSR, Romanized, Kosmicheskaya Programa SSSR, was the state space program of the Soviet Union, active from 1955 until the dissolution of the Soviet Union in 1991. Contrary to its American, European, and Chinese competitors, which had their programs run under single coordinating agencies, the Soviet space program was divided between several internally competing design bureaus led by Korolev, Kerimov, Keldysh, Yangel, Glushko, Chelemy, Makiev, Chertok and Reshetnev. Several of these bureaus were subordinated to the Ministry of General Machine Building. The Soviet space program served as an important marker of claims by the Soviet Union to its superpower status. Soviet investigations into rocketry began with the formation of the Gas Dynamics Laboratory in 1921, and these endeavors expanded during the 1930s and 1940s. In the years following World War II, both the Soviet and United States space programs utilized German technology in their early efforts at space programs. In the 1950s, the Soviet program was formalized under the management of Sergey Korolev, who led the program based on unique concepts derived from Konstantin Tsiolkovsky, sometimes known as the father of theoretical astronautics. Competing in the space race with the United States and later with the European Union and with China, the Soviet space program was notable in setting many records in space exploration, including the first intercontinental missile, R-7 Semyorka, that launched the first satellite, Sputnik 1, and sent the first animal, Laika, into Earth orbit in 1957, and placed the first human in space in 1961, Yuri Gagarin. In addition, the Soviet program also saw the first woman in space, Valentina Tereshkova, in 1963 and the first spacewalk in 1965. Other milestones included computerized robotic missions exploring the Moon starting in 1959, being the first to reach the surface of the Moon, recording the first image of the far side of the Moon, and achieving the first soft landing on the Moon. The Soviet program also achieved the first space rover deployment with the Lunokhod program in 1966, and sent the first robotic probe that automatically extracted a sample of lunar soil and brought it to Earth in 1970, Luna 16. The Soviet program was also responsible for leading the first interplanetary probes to Venus and Mars and made successful soft landings on these planets in the 1960s and 1970s. It put the first space station, Salyut 1, into low Earth orbit in 1971. And the first modular space station, Mir, in 1986. Its Interkosmos program was also notable for sending the first citizen of a country other than the United States or Soviet Union into space. Origins. Early Russian-Soviet efforts. The theory of space exploration had a solid basis in the Russian Empire before the First World War with the writings of the Russian and Soviet rocket scientist Konstantin Tsiolkovsky, 1857–1935, who published pioneering papers in the late 19th and early 20th centuries on astronautic theory, including calculating the rocket equation, and in 1929 introduced the concept of the multi-staged rocket. Additional astronautic and spaceflight theory was also provided by the Ukrainian and Soviet engineer and mathematician Yuri Kondratyuk, who developed the first known lunar orbit rendezvous law, a key concept for landing and return spaceflight from Earth to the Moon. The LOR was later used for the plotting of the first actual human spaceflight to the Moon. Many other aspects of spaceflight and space exploration are covered in his works. Both theoretical and practical aspects of spaceflight was also provided by the Latvian pioneer of rocketry and spaceflight Friedrich Zander, including suggesting in a 1925 paper that a spacecraft traveling between two planets could be accelerated at the beginning of its trajectory and decelerated at the end of its trajectory by using the gravity of the two planets' moons, a method known as gravity assist. Gas Dynamics Laboratory, GDL. The first Soviet development of rockets was in 1921, when the Soviet military sanctioned the commencement of a small research laboratory to explore solid-fuel rockets, led by Nikolai Tikhomirov, a chemical engineer, and supported by Vladimir Artemyev, a Soviet engineer. Tikhomirov had commenced studying solid and liquid-fueled rockets in 1894, and in 1915, he lodged a patent for self-propelled aerial and water surface mines. In 1928, the laboratory was renamed the Gas Dynamics Laboratory, GDL. The first test firing of a solid-fuel rocket was carried out in March 1928, which flew for about 1,300 meters. Further developments in the early 1930s were led by Georgy Langemak. In 1932, in-air test firings of RS-82 missiles from an Tupolev I-4 aircraft armed with 6 launchers successfully took place. Sergey Korolev, a key contributor to early Soviet efforts, came from a young Russian aircraft engineer, Sergey Korolev, who would later become the de facto head of the Soviet space program. In 1926, as an advanced student, Korolev was mentored by the famous Soviet aircraft designer Andrei Tupolev, who was a professor at his university. In 1930, while working as a lead engineer on the Tupolev TB-3 heavy bomber, he became interested in the possibilities of liquid-fueled rocket engines to propel airplanes. This led to contact with Zander, and sparked his interest in space exploration and rocketry. Group for the Study of Reactive Motion, GIRD. Practical aspects built on early experiments carried out by members of the Group for the Study of Reactive Motion, better known by its Russian acronym GIRD, in the 1930s, where Zander, Korolev and other pioneers such as the Russian engineers Mikhail Tikhonravov, Leonid Dushkin, Vladimir Vetchinkin and Yuri Pobedonostsev worked together. On August 18, 1933, the Leningrad branch of GIRD, led by Tikhonravov, launched the first hybrid propellant rocket, the GIRD-09, and on November 25, 1933, the Soviets' first liquid-fueled rocket GIRD-X. Reactive Scientific Research Institute, RNII. In 1933, GIRD was merged with GDL by the Soviet government to form the Reactive Scientific Research Institute, RNII, which brought together the best of the Soviet rocket talent, including Korolev, Langemak, Ivan Klemenov and former GDL engine designer Valentin Glushko. Early success of RNII included the conception in 1936 and first flight in 1941 of the RP-318, the Soviets' first rocket-powered aircraft, and the -82 rupees and -132 rupees missiles entered service by 1937. Which became the basis for development in 1938 and serial production from 1940 to 1941 of the Katyusha multiple rocket launcher, another advance in the reactive propulsion field. RNII's research and development were very important for later achievements of the Soviet rocket and space programs. During the 1930s, Soviet rocket technology was comparable to Germany's, but Joseph Stalin's Great Purge severely damaged its progress. In November 1937, Klemenov and Langemak were arrested and later executed. Glushko and many other leading engineers were imprisoned in the Gulag. Korolev was arrested in June 1938 and sent to a forced labor camp in Kolyma in June 1939. However, due to intervention by Tupolev, he was relocated to a prison for scientists and engineers in September 1940. World War II. During World War II, rocketry efforts were carried out by 3 Soviet design bureaus. RNII continued to develop and improve solid-fuel rockets, including the -82 rupees and -132 rupees missiles and the Katyusha rocket launcher, where Pobedonostsev and Tikhonravov continued to work on rocket design. In 1944, RNII was renamed Scientific Research Institute No. 1, RNII, and combined with Design Bureau OKB 293, led by Soviet engineer Viktor Bolkovatinov, which developed, with Alexei Isayev, Boris Chertok, Leonid Voskresensky and Nikolai Pilyugin, a short-range rocket-powered interceptor called Berezniak Isayev By-1. Special Design Bureau for Special Engines, OKBSD, was led by Glushko and focused on developing auxiliary liquid-fueled rocket engines to assist takeoff and climbing of prop aircraft, including the RDIKHZ, RD-2 and RD-3. In 1944, The RD-1 kHz auxiliary rocket motor was tested in a fast-climb Lavochkin La-7R for protection of the capital from high-altitude Luftwaffe attacks. In 1942, Korolev was transferred to OKBSD, where he proposed development of the long-range missiles D-1 and D-2. The third design bureau was Plant No. 51, OKB-51, led by Soviet-Ukrainian engineer Vladimir Chelemy, where he created the first Soviet pulsating air jet engine in 1942, independently of similar contemporary developments in Nazi Germany. German influence. During World War II, Nazi Germany developed rocket technology that was more advanced than the Allies, and a race commenced between the Soviet Union and the United States to capture and exploit the technology. Soviet rocket specialist was sent to Germany in 1945 to obtain V-2 rockets and worked with German specialists in Germany and later in the Soviet Union to understand and replicate the rocket technology. The involvement of German scientists and engineers was an essential catalyst to early Soviet efforts. In 1945 and 1946, the use of German expertise was invaluable in reducing the time needed to master the intricacies of the V-2 rocket, establishing production of the R-1 rocket and enable a base for further developments. On the 22nd of October 1946, 302 German rocket scientists and engineers, including 198 from the Zentralwerk, a total of 495 persons including family members, were deported to the Soviet Union as part of Operation Asurvihim. However, after 1947, the Soviets made very little use of German specialists and their influence on the future Soviet rocket program was marginal. Sputnik and Vostok. The Soviet space program was tied to the USSR's five-year plans and from the start was reliant on support from the Soviet military. Although he was single-mindedly driven by the dream of space travel, Korolev generally kept this a secret while working on military projects, especially after the Soviet Union's first atomic bomb test in 1949, a missile capable of carrying a nuclear warhead to the United States, as many mocked the idea of launching satellites and crewed spacecraft. Nonetheless, the first Soviet rocket with animals aboard launched in July 1951. The two dogs were recovered alive after reaching 101 kilometers in altitude. 2 months ahead of America's first such achievement, this and subsequent flights gave the Soviets valuable experience with space medicine. 84 to 88, 95 to 96, 118 because of its global range and large payload of approximately 5 tons. The reliable R-7 was not only effective as a strategic delivery system for nuclear warheads, but also as an excellent basis for a space vehicle. The United States announcement in July 1955 of its plan to launch a satellite during the International Geophysical Year greatly benefited Korolev in persuading Soviet leader Nikita Khrushchev to support his plans. 148 to 151. In a letter addressed to Khrushchev, Korolev stressed the necessity of launching a simple satellite in order to compete with the American space effort. Plans were approved for Earth-orbiting satellites, Sputnik, to gain knowledge of space, and 4 uncrewed military reconnaissance satellites, Zenit. Further planned developments called for a crewed Earth orbit flight by and an uncrewed lunar mission at an earlier date. After the first Sputnik proved to be a successful propaganda coup, Korolev, now known publicly only as the anonymous chief designer of rocket space systems 168 to 169, was charged to accelerate the crewed program, the design of which was combined with the Zenit program to produce the Vostok spacecraft. After Sputnik, Soviet scientists and program leaders envisioned establishing a crewed station to study the effects of zero gravity and the long-term effects on life forms in a space environment. Still influenced by Tsiolkovsky, who had chosen Mars as the most important goal for space travel, in the early 1960s, the Soviet program under Korolev created substantial plans for crewed trips to Mars as early as 1968 to 1970. With closed-loop life support systems and electrical rocket engines, and launched from large orbiting space stations, these plans were much more ambitious than America's goal of landing on the Moon. 333 to 337. Funding and support. The Soviet space program was secondary in military funding to the Strategic Rocket Forces ICBMs. While the West believed that Khrushchev personally ordered each new space mission for propaganda purposes, and the Soviet leader did have an unusually close relationship with Korolev and other chief designers, Khrushchev emphasized missiles rather than space exploration and was not very interested in competing with Apollo 351, 408, 426–427, while the government and the Communist Party used the program's successes as propaganda tools after they occurred. Systematic plans for missions based on political reasons were rare, one exception being Valentina Tereshkova, the first woman in space, on Vostok 6 in 1963. 351 missions were planned based on rocket availability or ad hoc reasons, rather than scientific purposes. For example, the government in February 1962 abruptly ordered an ambitious mission involving 2 Vostoks simultaneously in orbit launched, in 10 days' time, to eclipse John Glenn's Mercury Atlas 6 that month. The program could not do so until August, with Vostok 3 and Vostok 4, 354–361. Internal competition. Unlike the American space program, which had NASA as a single coordinating structure directed by its administrator, James Webb, through most of the 1960s, the USSR's program was split between several competing design groups. Despite the remarkable successes of the Sputnik program between 1957 and 1961 and Vostok program between 1961 and 1964, after 1958 Korolev's OKB-1 design bureau faced increasing competition from his rival chief designers, Mikhail Yangel, Valentin Glushko, and Vladimir Chelomey. Korolev planned to move forward with the Soyuz craft and N-1 heavy booster that would be the basis of a permanent crewed space station and crewed exploration of the Moon. However, Dmitry Ustinov directed him to focus on near-Earth missions using the Voskhod spacecraft, a modified Vostok, as well as on uncrewed missions to nearby planets Venus and Mars. Yangel had been Korolev's assistant, but with the support of the military, he was given his own design bureau in 1954 to work primarily on the military space program. This had the stronger rocket engine design team, including the use of hypergolic fuels, but following the Netherlands catastrophe in 1960, Yangel was directed to concentrate on ICBM development. He also continued to develop his own heavy booster design similar to Korolev's N-1, both for military applications and for cargo flights into space to build future space stations. Glushko was the chief rocket engine designer, but he had a personal friction with Korolev and refused to develop the large single-chamber cryogenic engines that Korolev needed to build heavy boosters. Chelomey benefited from the patronage of Khrushchev, 418, and in 1960 was given the plum job of developing a rocket to send a crewed vehicle around the Moon and a crewed military space station. With limited space experience, his development was slow. The progress of the Apollo program alarmed the chief designers, who each advocated for his own program as the response. Multiple, overlapping designs received approval, and new proposals threatened already approved projects. Due to Korolev's singular persistence, in August 1964, more than 3 years after the United States declared its intentions, the Soviet Union finally decided to compete for the Moon. It set the goal of a lunar landing in 1967, the 50th anniversary of the October Revolution, or 1968, 406 to 408, 420. At one stage in the early 1960s, the Soviet space program was actively developing multiple launchers and spacecraft. With the fall of Khrushchev in 1964, Korolev was given complete control of the crewed program. In 1961, Valentin Bondarenko, a cosmonaut training for a crewed Vostok mission, was killed in an endurance experiment after the chamber he was in caught on fire. The Soviet Union chose to cover up his death and continue on with the space program. After Korolev died in January 1966 from complications of heart disease and severe hemorrhaging following a routine operation that uncovered colon cancer. Kerem Kerimov, who had previously served as the head of the Strategic Rocket Forces and had participated in the State Commission for Vostok as part of his duties, was appointed chairman of the State Commission on Piloted Flights and headed it for the next 25 years, 1966 to 1991. He supervised every stage of development and operation of both crewed space complexes as well as uncrewed interplanetary stations for the former Soviet Union. One of Kerimov's greatest achievements was the launch of Mir in 1986. The leadership of the OKB-1 Design Bureau was given to Vasily Mishin, who had the task of sending a human around the Moon in 1967 and landing a human on it in 1968. Mishin lacked Korolev's political authority and still faced competition from other chief designers. Under pressure, Mishin approved the launch of the Soyuz 1 flight in 1967, even though the craft had never been successfully tested on an uncrewed flight. The mission launched with known design problems and ended with the vehicle crashing to the ground, killing Vladimir Komarov. This was the first in-flight fatality of any space program. Following this tragedy and under new pressures, Mishin developed a drinking problem. The Soviets were beaten in sending the first crewed flight around the Moon in 1968 by Apollo 8, but Mishin pressed ahead with development of the flawed Super Heavy N-1, in the hope that the Americans would have a setback, leaving enough time to make the N-1 workable and land a man on the Moon first. There was a success with the joint flight of Soyuz 4 and Soyuz 5 in January 1969 that tested the rendezvous, docking, and crew transfer techniques that would be used for the landing, and the LK lander was tested successfully in Earth orbit. But after 4 uncrewed test launches of the N-1 ended in failure, the program was suspended for 2 years and then cancelled, removing any chance of the Soviets landing men on the Moon before the United States. Besides the crewed landings, the abandoned Soviet moon program included the multi-purpose moonbase Vesta, first detailed with developed mock-ups of expedition vehicles and surface modules. Following this setback, Chelomey convinced Ustinov to approve a program in 1970 to advance his Almaz military space station as a means of beating the US's announced Skylab. Mishin remained in control of the project that became Salyut, but the decision backed by Mishin to fly a 3-man crew without pressure suits rather than a 2-man crew with suits to Salyut 1 in 1971 proved fatal when the re-entry capsule depressurized, killing the crew on their return to Earth. Mishin was removed from many projects, with Chelomey regaining control of Salyut. After working with NASA on the Apollo-Soyuz, the Soviet leadership decided a new management approach was needed, and in 1974, the N-1 was cancelled and Mishin was out of office. The Design Bureau was renamed NPO Energia with Glushko as chief designer. In contrast with the difficulty faced in its early crewed lunar programs, the USSR found significant success with its remote moon operations, achieving 2 historical firsts with the automatic Lunokhod and the lunar sample return missions. The Mars probe program was also continued with some success, while the explorations of Venus and then of the Halley Comet by the Venera and Vega probe programs were more effective. In spite of many other Soviet allied nations contributing to the national space program, the Soviet program was mostly inherited by the Russian Federation and fewer facilities to Ukraine after the dissolution of the Soviet Union in 1991. The primary spaceport, Baikonur Cosmodrome, is now in Kazakhstan, which leases the facility to Russia. Program secrecy. The Soviet space program had withheld information on its projects predating the success of Sputnik, the world's first artificial satellite. In fact, when the Sputnik project was first approved, one of the most immediate courses of action the Politburo took was to consider what to announce to the world regarding their event. The Telegraph Agency of the Soviet Union, TASS, established precedents for all official announcements on the Soviet space program. The information eventually released did not offer details on who built and launched the satellite or why it was launched. The public release revealed, "There is an abundance of arcane scientific and technical data," as if to overwhelm the reader with mathematics in the absence of even a picture of the object. What remains of the release is the pride for Soviet cosmonautics and the vague hinting of future possibilities then available after Sputnik's success, The Soviet space program's use of secrecy served as both a tool to prevent the leaking of classified information between countries and also to create a mysterious barrier between the space program and the Soviet populace. The program's nature embodied ambiguous messages concerning its goals, successes, and values. Launchings were not announced until they took place. Cosmonaut names were not released until they flew. Mission details were sparse. Outside observers did not know the size or shape of their rockets or cabins or most of their spaceships, except for the first Sputniks, lunar probes and Venus probe. However, the military influence over the Soviet space program may be the best explanation for this secrecy. The OKB-1 was subordinated under the Ministry of General Machine Building, tasked with the development of intercontinental ballistic missiles, and continued to give its assets random identifiers into the 1960s. For example, the Vostok spacecraft was referred to as Object IIF 63 feet, while its launch rocket was Object 8K72K. Soviet defense factories had been assigned numbers rather than names since 1927. Even these internal codes were obfuscated. In public, employees used a separate code, a set of special post office numbers, to refer to the factories, institutes, and departments. The program's public pronouncements were uniformly positive. As far as the people knew, the Soviet space program had never experienced failure. According to historian James Andrews, with almost no exceptions, coverage of Soviet space exploits, especially in the case of human space missions, omitted reports of failure or trouble, according to Dominic Phelan in the book Cold War. Space sleuths. The USSR was famously described by Winston Churchill as a riddle, wrapped in a mystery, inside an enigma, and nothing signified this more than the search for the truth behind its space program during the Cold War. Although the space race was literally played out above our heads, it was often obscured by a figurative, space curtain that took much effort to see through. Projects and accomplishments. Completed projects. The Soviet space program's projects include Almaz space stations, Cosmos satellites, Photon, lunar, moon flybys, orbiters, impacts, landers, rovers, sample returns. Mars probe program, Meteor meteorological satellites, Molniya communications satellites, Mir space station, Proton satellites, Phobos Mars probes program, Salyut space stations, Soyuz program spacecraft, Sputnik satellites, TKS spacecraft, Venera, Venus probes program, Vega program, Venus and Comet Halley probes program, Vostok program spacecraft, Voskhod program spacecraft, Zond program. Notable firsts. 2 days after the United States announced its intention to launch an artificial satellite, on July 31, 1955, the Soviet Union announced its intention to do the same. Sputnik 1 was launched on October 4, 1957, beating the United States and stunning people all over the world. The Soviet space program pioneered many aspects of space exploration. 1957, first intercontinental ballistic missile and orbital launch vehicle, the R-7 Semyorka. 1957, first satellite, Sputnik 1. 1957, first animal in Earth orbit, the dog Laika on Sputnik 2. 1959, first rocket ignition in Earth orbit, first man-made object to escape Earth's gravity, Luna 1. 1959, first data communications, or telemetry, to and from outer space, Luna 1. 1959, first man-made object to pass near the Moon, first man-made object in heliocentric orbit, Luna 1. 1959, first probe to impact the Moon, Luna 2. 1959, first images of the Moon's far side, Luna 3. 1960, first animals to safely return from Earth orbit, the dogs Belka and Strelka on Sputnik 5. 1961, first probe launched to Venus, Venera 1. 1961, first person in space, international definition, and in Earth orbit, Yuri Gagarin on Vostok 1, Vostok program. 1961, first person to spend over 24 hours in space German Titov, Vostok 2, also first person to sleep in space. 1962 – First dual-crewed spaceflight, Vostok 3 and Vostok 4. 1962 – First probe launched to Mars, Mars 1. 1963 – First woman in space, Valentina Tereshkova, Vostok 6. 1964 – First multi-person crew, 3, Voskhod 1. 1965 – First extravehicular activity, EVA, by Alexei Leonov, Voskhod 2. 1965 – First radio telescope in space, Zond 3. 1965 – First probe to hit another planet of the Solar System, Venus, Venera 3. 1966 – First probe to make a soft landing on and transmit from the surface of the Moon, Luna 9. 1966 – First probe in lunar orbit, Luna 10. 1966 – First image of the whole Earth disk, Molniya 1. 1967 – First uncrewed rendezvous and docking, Cosmos 186, Cosmos 188. 1968 – First living beings to reach the Moon, circumlunar flights, and return unharmed to Earth, Russian tortoises and other lifeforms on Zond 5. 1969 – First docking between two crewed craft in Earth orbit and exchange of crews, Soyuz 4 and Soyuz 5. 1970 – First soil samples automatically extracted and returned to Earth from another celestial body, Luna 16. 1970 – First robotic space rover, Lunokhod 1 on the Moon. 1970 – First full interplanetary travel with a soft landing and useful data transmission. Data received from the surface of another planet of the Solar System, Venus, Venera 7. 1971 – First space station, Salyut 1. 1971 – First probe to impact the surface of Mars, Mars 2. 1971 – First probe to land on Mars, Mars 3. 1971 – First armed space station, Almaz. 1975 – First probe to orbit Venus, to make a soft landing on Venus, first photos from the surface of Venus, Venera 9. 1980 – First Asian person in space, Vietnamese cosmonaut Pham Tuan on Soyuz 37, and first Latin American, Cuban and person with African ancestry in space, Arnaldo Tamayo Mendes on Soyuz 38. 1984 – First Indian astronaut in space, Rakesh Sharma on Soyuz T-11, SALYUT-7 space station. 1984 – First woman to walk in space, Svetlana Savitskaya, Salyut 7 space station. 1986 – First crew to visit two separate space stations, Mir and Salyut 7. 1986 – First probes to deploy robotic balloons into Venus' atmosphere and to return pictures of a comet during close flyby Vega 1, Vega 2. 1986 – First permanently crewed space station, Mir, 1986 to 2001, with a permanent presence on board, 1989 to 1999. 1987 – First crew to spend over 1 year in space, Vladimir Titov and Musa Manarov on board of Soyuz TM-4 Mir. 1988 – First fully automated flight of a spaceplane, Buran. Incidents, failures, and setbacks. Accidents and cover-ups. The Soviet space program experienced a number of fatal incidents and failures. The first official cosmonaut fatality during training occurred on March 23, 1961, when Valentin Bondarenko died in a fire within a low-pressure, high-oxygen atmosphere. On April 23, 1967, Soyuz 1 crashed into the ground at 90 miles per hour, 140 kilometers per hour, due to a parachute failure, killing Vladimir Komarov. Komarov's death was the first in-flight fatality in the history of spaceflight. The Soviets continued striving for the first lunar mission with the huge N-1 rocket, which exploded on each of 4 uncrewed tests shortly after launch. The Americans won the race to land men on the Moon with Apollo 11 on July 20, 1969. In 1971, the Soyuz 11 mission to stay at the Salyut 1 space station resulted in the deaths of 3 cosmonauts when the re-entry capsule depressurized during preparations for re-entry. This accident resulted in the only human casualties to occur in space, beyond 100 kilometers, 62 miles, as opposed to the high atmosphere. The crew members aboard Soyuz 11 were Vladislav Volkov, Georgy Dobrovolsky, and Viktor Patsayev. On April 5, 1975, Soyuz 7 KT No. 39, the second stage of a Soyuz rocket carrying 2 cosmonauts to the Salyut 4 space station malfunctioned, resulting in the first crewed launch abort. The cosmonauts were carried several thousand miles downrange and became worried that they would land in China, which the Soviet Union was having difficult relations with at the time. The capsule hit a mountain, sliding down a slope and almost slid off a cliff. However, the parachute line snagged on trees and kept this from happening. As it was, the two suffered severe injuries and the commander, Lazarev, never flew again. On March 18, 1980, a Vostok rocket exploded on its launch pad during a fueling operation, killing 48 people. In August 1981, Cosmos 434, which had been launched in 1971, was about to re-enter. To allay fears that the spacecraft carried nuclear materials, a spokesperson from the Ministry of Foreign Affairs of the USSR assured the Australian government on 26 August 1981 that the satellite was an experimental lunar cabin. This was one of the first admissions by the Soviet Union that it had ever engaged in a crewed lunar spaceflight program. 736 in September 1983, a Soyuz rocket being launched to carry cosmonauts to the Salyut 7 space station exploded on the pad, causing the Soyuz capsule's abort system to engage, saving the 2 cosmonauts. On board Buran, the Soviet Buran program attempted to produce a class of spaceplanes launched from the Energia rocket, in response to the U.S. Space Shuttle. It was intended to operate in support of large space-based military platforms as a response to the Strategic Defense Initiative. Buran only had orbital maneuvering engines. Unlike the Space Shuttle, Buran did not fire engines during launch, instead relying entirely on Energia to lift it out of the atmosphere. It copied the airframe and thermal protection system design of the U.S. Space Shuttle orbiter, with a maximum payload of 30 metric tons, slightly higher than that of the Space Shuttle, and weighed less. It also had the capability to land autonomously. Due to this, some retroactively consider it to be the more capable launch vehicle. By the time the system was ready to fly in orbit in 1988, strategic arms reduction treaties made Buran redundant. On November 15, 1988, Buran and its Energia rocket were launched from Baikonur Cosmodrome in Kazakhstan, and after 2 orbits in 3 hours, glided to a landing a few miles from its launch pad. While the craft survived that re-entry, the heat shield was not reusable. This failure resulted from United States counter-intelligence efforts. After this test flight, the Soviet Ministry of Defense would defund the program, considering it relatively pointless compared to its price. Polyus satellite. The Polyus satellite was a prototype orbital weapons platform designed to destroy Strategic Defense Initiative satellites with a megawatt carbon dioxide laser. Launched mounted upside down on its Energia rocket, its single flight test was a failure when the inertial guidance system failed to rotate it 180 degrees and instead rotated a complete 360 degrees. Cancelled projects. Energia rocket. The Energia was a successfully developed super heavy lift launch vehicle which burned liquid hydrogen fuel. But without the Buran or Polyus payloads to launch, it was also cancelled due to lack of funding on dissolution of the USSR. Interplanetary projects. Mars missions. Heavy rover Mars 4NM was going to be launched by the abandoned N1 launcher between 1974 and 1975. Mars sample return mission Mars 5NM was going to be launched by a single N1 launcher in 1975. Mars sample return mission Mars 5M or Mars 79 was to be double launched in parts by Proton launchers, and then joined in orbit for flight to Mars in 1979. Vesta. The Vesta mission would have consisted of 2 identical double-purposed interplanetary probes to be launched in 1991. It was intended to fly by Mars, instead of an early plan to Venus, and then study 4 asteroids belonging to different classes. At 4 Vesta a penetrator would be released. Tsiolkovsky. The Tsiolkovsky mission was planned as a double-purpose deep interplanetary probe to be launched in the 1990s to make a slingshot flyby of Jupiter and then pass within 5 or 7 radii of the Sun. A derivative of this spacecraft would possibly be launched towards Saturn and beyond.